Hello friends, today we are going to talk about the benzyne reaction. It is one of the important reaction in organic synthesis and it is widely used for many reactions to prepare a highly complex molecule. Let us see in detail. So, benzynes are the compound formed by the elimination of a living group you, by abstracting the alpha proton to generate the triple bond intermediate. This triple bond intermediate can be represented using the deuterionic intermediate or it can be also represented by the diradical intermediate. So these are nothing but the representation of benzyne intermediate. This benzyne intermediate is highly reactive towards the nucleophilic substitution reaction. So it is used to generate the many new compounds using the benzyne intermediate. So let us see why this benzyne intermediate is highly reactive for the nucleophilic substitution reaction. The main reason is that when we talk about the benzyne intermediate as compared to the alkyne, the bond formed in the aromatic ring is less than 180 degree. So this bond form is due to the poor overlapping of p orbital, due to which it is a weak in nature. So it is absorbed at the lower frequency in IR at 1846 wave number. Whereas in alkyne, the bond is the linear and it is about 180 degree and it is less strained as compared to the triple bond in the benzyne, due to which it forms a strong overlapping of p orbital generating this strong triple bond. So due to this factor, it is absorbed at the high wave number as compared to the benzyne. So due to this strained nature of a triple bond, it is highly reactive for the nucleophilic substitution reaction. This is a mechanism or reaction by which benzyne intermediate is generated. In the first step is the dehydrogenation. When we use the strong base, the alpha proton is abstracted, generating the triple bond by removing the leaving group. This triple bond form is highly reactive towards the nucleophilic substitution reaction. The elimination is formed due to the even-Steven mechanism, or it can be considered sine coplanar E2 elimination. Once this benzyne intermediate form, it is attacked by the nucleophile, generating the nucleophilic addition product. In the next step, there is a proton abstraction to regenerate the aromatic character of the new substituted compound. In this case, the formation of an benzyne intermediate is a rate determining step. Usually it is slow, so it is a rate determining step. Let us see the history of benzyne intermediate. In 1902, Stromer and Collard observed that the reaction of an 3-bromo-benzofuran with an base generated the 2-ethoxy benzofuran. So interestingly, they investigate the reaction mechanism and it was found that due to the use of strong base, the alpha proton next to the oxygen atom is abstracted and triple bond is generated to generate the benzyne intermediate. In the next step, the reactive uh, uh, adjacent carbon near the heteroatom, that is oxygen atom, is attacked by the nucleophile to generate the 2-ethoxybenzofuran. Similarly, Wittig also discovered the deuterionic intermediate by reacting the fluorobenzene with an phenyl lithium, which generated the biphenyl. So in this case, the Wittig investigate the reaction mechanism and it was found that there is a formation of deuterionic intermediate. In the first step, there is a lithiation to get the lithiated derivative. In the next step, there is the elimination to generate the benzyne intermediate or deuterionic intermediate. In the last step, the phenyl attack at the electropositive carbon and lithium at the electronegative carbon to generate the biaryl or biphenyl derivative. Let us see the different reactions which are used to generate the aryne or a benzyne. The first step, as we have discussed earlier in the first slide, where we have generated the benzene using the reaction of an aryl halide by extracting the alpha proton to generate the benzene. It can be also generated by using the trimethylsilyl aryl triplet. By using the tetrabutyl ammonium fluoride, we generate the benzene. Benzene can also be generated using the benz-triazole derivative. In the first step, there is amination followed by the reaction with and late tetraacetate to generate the benzene. These are the common technique by which benzene can be generated. This is the C14 labeling experiment conducted by the John D. Robert. We showed that the reaction of an chlorobenzene, where the chloro is attached to the 14C carbon, is reacted with a sodamide to generate the benzene. So in benzene, one of the carbon is C14, and this benzene is reacted with a nucleophile. It generated the two regioisomer. In the first case, the nucleophile is attached to the uh, C14 carbon. In the second product, the nucleophile is attached to the another carbon when there is a no C14. So this indicates that there is a formation of an two product when we have the different substitution in the arene. So let us see this kind of a reaction in detail. As I have told you, we will get the two product when we have the different substitution or carbon 13 or 14 labeling. In the first scenario, this is our leaving group and we have the substitution at para or meta position. We will get only one benzene intermediate and the product form will be only single. But when we have the meta substitution with respect to leaving group, so we have now two acidic proton which can be abstracted, generating the two benzenes such as A and B. A is generated when proton A is abstracted and B is generated when intermediate benzene B is generated when the proton B is abstracted. So in this case, we will get the mixture of a two possible regioisomer when we have the meta substitution with respect to leaving group. Let us see the application of benzene reaction. This is the first example and classical reaction from a pericyclic reaction of Aryne where it go the 2 plus 2 cycloaddition reaction. This is a benzene which react with the furan to generate the uh, new derivative. Another interesting example is the synthesis of herb indole. This was reported in 2009 by Busek and co-worker. In this reaction, the benzene is generated from the indole derivative, and this indole is reacted with a cyclopentadiene to generate the intermediate. Upon the sequence of reaction, decyclation, the herb indole is generated. Another example is of the synthesis of cryptayustolene or cryptavolene. In this case, benzene is generated and it is intramolecularly cyclized to generate the intermediate which is used for the synthesis of cryptayustolene or cryptavolene. Another example is that the synthesis of tetracyclic meroterpenoid lifagal. In this case, the benzene is generated by the reaction of an LDA with an bromo derivative. So this proton is abstracted, generating the benzene. In the next step, the benzene generated it intramolecularly cyclized to generate the intermediate. Upon sequence of reaction, lipaglar is generated. Hope you guys like my video. Please share and subscribe.